Hi students, today in this video let me discuss about how to implement stack using LIST ADT. I think you are very familiar with the definition of LIST ADT. List means collection of nodes. Same thing, stack means last in first out. Okay, in the last video we have implemented the stack using array. You already know the difference between array and list ADT. In array, the insertion, deletion, all these operation is little bit slow compared to the list ADT. It's not efficient. So that's why we're going to implement the stack using list ADT. I think you're all familiar with different kinds of list operations. That is insert at first last middle, delete at first last middle, display. Likewise in stack, the operations are push, pop and display. Okay. So same thing, same concept of push and pop, but we're going to use the list ADT. So for list ADT, first you have to include stdio.h. I think you are familiar with this declaration of node. For to declare a node, you need a struct node. In node, it consists of two parts. One is data part and next one is address part. Then close your struct. As usual, the same procedure. Then start your main function. In main function, create a struct variable. Structured variable. Always the first node you represent as head node. Initially it is null. Then you need a temp node for to create a new node. Then you need a temporary variable tp for to traverse in the list. This all you are very familiar with this concept. See here, once you declare the variable for your struct node, then next one is you have to start your do statement. In do statement, the operations are first one is push, pop and display. Then read the choice variable ampersand ch. Then start the switch case. In case 1 is nothing but push. I told no, in while we going to implement the stack using list, a push operation means always you have to insert the new item at the front end. So that is insert at first. Okay, remember this push operation, you have to use insert at first in list. So as usual, first you have to check whether your head pointer is null. If your head pointer is null, then your list is empty. So first you have to read the new node. For read the new node, as usual, temp, allocate memory address for temp. So struct node star, then malloc, then size of struct node. As usual, the same procedure. As usual, create the memory allocation. Okay, once you are created the memory, then use scanf to read the value directly. So ampersand temp to the data, ampersand temp to the data, then initially the next field. Okay, initially the next field is null. This is everyone familiar with creation of new node. Okay, once you created a new node, then the temp become the head node. Now the temp become the head node. Okay, suppose if there is a node, already there is a head node, means then directly you move on to the else part. So in else part, this is the insert at first. So insert at first means temp to the next equal to temp to the next equal to head. I think everyone familiar with this pseudocode. Then head equal to temp. This is the insert at full pseudocode. So case 1 end with case 1. This is the push operation. Insert at first. Okay. Then case 2. Case 2 is nothing but pop. Pop means Pop means delete at first. Pop means delete at first. So delete at first, as usual. First you have to check whether your head pointer is null. If so, if your head pointer is null, then you just simply display yes, list is stack is empty. Stack is empty. Otherwise you just directly move on to the else part. So in else part you just assign in else part you just assign TP equal to head in order to traverse, TP equal to head. Then the first node, you have going to delete the first node. So head equal to, hereafter head equal to TP to the next, then free of TP. So hereafter the next bottom node is the head node, that you going to delete the first node, that is deleted first. Once you deleted first, then give the break statement. Then the case 3 is nothing but display. For display you are going to do the traverse. So as usual the same thing, just copy the code. See here, if your head is null, simply display yes, the stack is empty. Otherwise in else part assign TP equal to head, then traverse. So traverse means while TP is not equal to null, until TP not equal to null, you have to print the value. So print the %d, then comma TP to the data, then TP to the data, then traverse. So TP equal to TP to the next. I think everyone familiar with this. Next, that's it. Okay, then this is while else. So there is a break for case 3, break, then switch. This one is while. So while your choice is less than or your choice is less than 4, then return of 0. Okay, we finished the case. So case 1, case 2, case 3. Again now we are going to compile and run. While compile and run, it read the choice. So the first choice is push. The first choice is push. I am going to insert 10, again push, 20, again push, 30. Now I am going to display. You can able to see the output here, 30, 20, 10. Okay, now pop means 30 will deleted. See here, so 30 will deleted. The output is 20 and 10. Okay, now you are able to you are clear with this concept. Okay, thank you.